We built an interactive character animation system that creates agile, interactive and controllable, physically simulated characters equipped with various motor skills learned from unorganized motion data. Our control system has two components, the motion generator and the tracking controller. The motion generator predicts the future motions from the character state and the goal given by the user. The tracking controller simulates and controls the character to follow the prediction. At the presence of an external perturbation, the character's state may change unexpectedly. The motion generator dynamically adapts to the new state and updates the prediction such that the character can respond to physical interactions and keep moving appropriately to the given goal. Both the motion generator and tracking controller are deep networks learned from an unorganized collection of motion clips. The training dataset is often insufficient for learning deep networks. The data augmentation step enriches combinatorial variations and spatio-temporal variations in the dataset. The motion generator consists of multiple layers of LSTM units. The tracking controller is a policy network of multiple fully connected layers. Both networks are learned from the augmented dataset to predict, simulate, and control the character's motion given the control parameters. The zombie character learned this control policy from a few motion clips of 32 seconds playtime, including several steps of straight walking and turning. The zombie can walk to an arbitrary target position by actuating its joint under gravity. The user can reposition the target interactively at any time. The zombie can endure external pushes and impulses robustly. The gorilla learned its control policy from a 10-second dataset including side steps and roaring. Even with the small dataset, the data augmentation algorithm enriches combinatorial and spatiotemporal variabilities substantially. The improved variabilities in the training data allow the character to be controlled interactively. Chicken hopping is a game of hopping on one leg and bumping the opponents to make them fall over. The character learned to play the game from a motion dataset of only 14 seconds. The data augmentation algorithm generated a richer dataset of 5.5 minutes of playtime. The controller learned from the augmented data allows the character to move and turn in any direction while hopping continuously. In the multiplayer scene, two teams play the game with 3 players in each team. Each player moves to the nearest opponent and bumps while maintaining its balance against the impulse. The user is controlling the character to rush through obstacles. The character is equipped with running, jumping, and rolling motor skills. The robustness of our tracking controller allows dynamic actions to be triggered one after another immediately without delays. The immediacy of control makes the character agile and responsive. Our character can dribble the ball while both the full body and the ball are physically simulated. Since our character does not have fingers yet, we attach the ball to the palm when the ball is in the hand and release the ball when it bounces off the ground. The motion generator was learned from a basketball dataset of 12 minutes, which includes a variety of motor skills, such as walking, running, rapid turning, and hand switching while dribbling the ball continuously. The control policy is learned in 2 steps. In the first step, we train the dribbling motion without the ball. The second step of learning refines the motion of the hands to push the ball and catch it precisely. In this example, the character walks and runs under the user's control. The character may trip over the obstacle and stand up again. The future prediction from the motion generator guides the tracking controller continuously to deal with unexpected user interventions and physical events. The user controls 2 characters simultaneously to have them punch and kick each other. The 2 characters are simulated and controlled by the same motion generator and the same tracking controller. They learn to throw punches and kicks precisely at targets from unorganized 3-minute motion clips.